All right, let's do one more. This one has some trig in it because we haven't done that yet. Analyze and sketch the graph of f of x is equal to cosine x divided by 1 plus sine x. How do we start? We start with the domain. Okay, cosine. Well, you can stick anything in for x that you want to for cosine. Same thing with sine, but since this thing is a fraction, we know that that denominator cannot be equal to 0. So to get our domain here, what we'll do is we'll just go 1 plus sine x is not equal to 0, and then solve that as if it's an equation. Sine x is not equal to negative 1, and then you can take the arc sine of this, but that's only going to give you one value. So instead, I'm going to look at the unit circle. Where is sine equal to negative 1? It's way down here. That is at either 3 pi over 2, but I'm going to start with negative pi over 2. Right? Okay, so x is equal to, not equal to, negative pi over 2. And does it happen again? It happens a whole bunch. As a matter of fact, if I just go all the way around again, about 2 pi, I'm going to hit it again at 3 pi over 2. 3 pi over 2. And again, we can see that the distance between those two things is 2 pi, and that is going to be our period. This is periodic. It's going to repeat over and over and over again. What's the next one, you ask? Well, just add 2 pi's to that. That's like a 5 pi over 2 and so on. Okay, all right. So in other words, our domain here is the set of all x such that x is not equal to negative pi over 2. But if I want to kind of generalize this, I'm just going to add in a multiple of 2 pi. And I can do that with, say, something like 2 n pi. Doesn't really matter where that n goes. You can put it at the end, 2 pi n, whatever. Okay, so here's our domain. There's the first part of it. Now, you might be asking yourself, because I know I am, what's happening at each one of these things? At, say, a negative pi over 2, is it going to be like an asymptote? Is it going to be a whole? Well, we can figure that out by taking the limit. Let's take one of these values specifically. We'll take that negative pi over 2. Take the limit as x approaches a negative pi over 2. And let's say, for example, if we had ourselves a graph here. Let me just kind of sketch a graph. Boop. Here's my x and my y axis. All right, and let's throw, let's say that this right here is a negative pi over 2, right? And then over here is going to be my 3 pi over 2. So it's within this little interval here. And if I am going to find the limit as x approaches negative pi over 2, I'm going to have to do that from this left-hand side here. And by left, I mean right. Meh, okay, whatever. All right, and then this is the, no, cosine. It's right there. It's right there on the screen. Come on. Over 1 plus sine x. Okay, let's go ahead and do some direct substitution. The cosine of negative pi over 2, cosine is the x value, that's 0, over 1 plus, and then the sine is a negative 1. So maybe I'll just do minus 1, which is 0 over 0. Hey, this is L'Hopital's rule. Hey, you know what? In the past, every single time we've seen 0 over 0, didn't that give us like a hole in our graph? Question mark? All right, well, I don't know. Since this is L'Hopital's rule, let's go ahead and take the derivative of the top and the bottom here. Limit as x approaches negative pi over 2 from the right. Derivative of cosine is a negative sign. And derivative of 1 is 0. Derivative of sine is cosine. And sine over cosine, I can just rewrite that as a tangent. So limit x approaches a negative pi over 2 from the right of negative tangent x. All right, if you were to plug in a negative pi over 2 into tangent, we would get, it's undefined. It's either plus or minus infinity. Here, let's take a look at the graph of tangent. So, do. And then for tangent, maybe we've got something like this green color here. Yeah. Anyway, let's switch back to blue. So we're talking about negative pi over 2, which is this asymptote here, and we're approaching it from the right-hand side. This is going to go down to negative infinity, as we can see. But we're taking negative of negative infinity, which makes this a positive infinity. What's that mean? That means it turned out not to be a hole, and instead is a vertical asymptote. That's how you spell the word vertical. There we go. Asymptote. I have to sound it out every single time. All right, well, that's one side of that thing. Here, let's maybe see what's happening over here on the other side. Perhaps we can either do that or we can do the one at, let's do the one actually at 3 pi over 2. Let's do this one. Yeah, 3 pi over 2. All right, I'll do the limit one more time. Maybe just one more time. Maybe like 4 more times. X approaches 3 pi over 2, and then this time we're going to have to approach it from the left. Doop. And it's the same function, cosine x over 1 plus sine x. Well, a 3 pi over 2 is in the exact same place. It's in the exact same place as negative pi over 2, so it's still going to give us a 0 over 0, which means that, hey, we're going to use our L'Hopital's rule on this thing. Okay, and then take the derivatives of the top and the bottom. It's still equal to exactly the same thing, so the limit as x approaches 3 pi over 2, this time from the left, and just as we saw here, it's a negative sine over cosine, which turns into be a negative tangent. So all of that worked out exactly the same, but now we're talking about 3 pi over 2, and this one's from the left. So let's go back to our graph. Got to draw in another little asymptote here. Okay, so 3 pi over 2, this time is this asymptote. It's this one. And we want to approach it from the left-hand side. So here we can see that it's going up to positive infinity. So this one, a positive infinity. Right? But it's a negative of this positive infinity. We can see that this is a negative infinity. Once again, we have ourselves a vertical asymptote. Okay, and since this thing is periodic, it's going to happen over and over again. And what this also means is instead of doing the whole entire domain, you only consider one period. So we're going to consider, and then the other stuff is just going to be duplicated from that. So we're just going to go from negative pi over 2 to 3 pi over 2. And then maybe even make like a mathematical stamp, like an ink stamp, and then just stamp the rest of it. Yeah, that's how we're going to do it. All right, so let's throw in some asymptotes, shall we? So negative pi over 2, that's this guy. And then we want to go pi from that. So 3 pi over 2, no, not pi, 2 pi from that. So pi is 2 of these boxes. So here's 1 pi, and then here's 2 pi's. So it's dip, 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 dip. So you can see that it's a total of 4 boxes. So throw in the rest of them. And then we'll see, do we have enough room? 1, 2, 3, 4. Of course we have enough room. There we go. So we are only going to consider this one here, this little interval here, and then we'll just duplicate it everywhere else, okay? So we'll start that process when we come back in the next video.